Draw the Lewis structure for nitrogen trichloride. Draw the shape. Determine if it's polar or not polar. And give me the net dipole if it's polar. You got a lot going on in this problem. Draw the Lewis structure. Go back and check what you got to do. So the first thing we have to do, this will bother me. Yeah. First thing we've got to do is draw the Lewis structure for NCl3. So 5 electrons for nitrogen, 7 times 3 is 21 electrons, gives me 26 electrons. Central atom bonds to the terminal atoms, complete the octets on the terminal. I've used up 8 times 3 is 24 electrons. That means there is a lone pair on the nitrogen. So that's the Lewis structure. It's not an ion, so I'm not going to use brackets. So this is the answer to part A. Okay? Next question. Draw the shape of the molecule. Well, what's its geometry? So the shape, it's 4 regions with a lone pair. And if we memorize 4 regions, lone pair is going to cause these 3 regions to become closer together. So it's trigonal. Pyramidal. That's the shape. Completing the octets. Okay, so there's your shape, 3-dimensional shape. We had to draw it, draw the shape, determine if it's polar or non-polar. Well, the shape does help me determine that because I can see which way the bond. Now, nitrogen and chlorine are very close, so you just got a point if you drew a dipole in either direction. So nitrogen and chlorine, there's not a big dipole here. I don't really want to draw that on my Lewis structure. So what we want to do here is, if we think about each chlorine pulling down here, we see that the dipoles are not balanced. They're not balanced. So this is definitely polar, and we would say because dipoles, we'll say bond dipoles. Dipoles for each of these bonds, dipoles do not cancel. When the dipoles don't cancel, you have a net dipole. We have to draw it in this molecule, and so it would, if you take chlorine to be your most electronegative, it's pointing down through the center. If nitrogen, then it's pointing up this way. So, like that. You got it either way. If you main points here were this one, you got a point for the structure, and you got a point if you drew a dipole somewhere, either down or up. I should have put these as fluorines, and it would have definitely been down, or hydrogens, it would have been up. So I accepted either answer on that. Draw the Lewis structure for H2S. So let's count our electrons. We have 2 for hydrogen, 6 for the sulfur, and oxygen's group, that gives me 8 electrons. And so sulfur is central, 2, 4, 6, 8. We're done. That is the Lewis structure. So you get a point if you did that. Give the molecular geometry and the hybridization. Well, it's 4 regions, but I have 2 lone pairs now. 4 regions with 2 lone pairs is V-shaped. The other word you could use for it is bent. Either one of those was good, and that got you a point. And then the hybridization. How do we get hybridization? Hybridization, we count regions. How many regions? We've already done that. It's 4 a region. So 1, 2, single bonds count as another region, 3, 4. So 4 regions. That means we mixed 4 orbitals. So it was S. We need 3 more orbitals. We pick up the P first. If we need a 5th region, we go get a D orbital from the set of D orbitals. So if it's 4 regions, it's automatically sp3 hybridized, and that got you 1 more point. So that's 3 points. Number 9, a nitrogen-hydrogen compound consists of 92.8% nitrogen, 7.2%. Hydrogen has a molar mass of 28, and appropriate structure of the molecule is. You should have gotten your empirical formula to be, let's see, nitrogen 92.8 grams over 14, and then hydrogen 7.2 over 1. So your mole ratio is going to be 7.2. Get a calculator. .63. And so if we divide by the smallest, we get a 1, and that's basically going to be to 1.08, so it's 1 to 1. So you've got a 1-to-1 mole ratio. So your empirical formula is NH. Well, it has a mass of 15, right? So how many of these units am I going to get? It's going to get me close to the 28. Well, it's 2. So the molecular formula you would have to guess is 2 because there's nothing else you could do to 15. If you do 3, you're way over 28. So this was a guideline for us. So we're looking for the correct Lewis structure for N2H2. Definitely got too many hydrogens. This might be it, or this might be it. And so we need to look at formal charges help us determine which Lewis structure is better. And so let's do formal charges. So 1, 2, 3, 4, 5. No formal charge here. 1, 2, 3, 4, 5. So formal charges add up to 0 in that structure. And here, the formal charges are 1, 2, 3, 4. So we're short the valence. 1, 2, 3, 4, 5, 6. We have 1 past the valence. So this structure has formal charges. This has 0 formal charges. That's always your best for Lewis structure. So that's how you work that one. What did I do number 9? No, I did not. Well, that is 9. Okay. What does the value of N have in the silicon hexafluoride ion? So SiF6, we're looking for the charge on the ion. Okay, a lot of you didn't read the ion. So N is the charge. It's a superscript. So basically what you have to do is you have to figure out if you had this, okay, you know you've got silicon and you've got 6 things around it. 6 is the most you can have, by the way, right? Our regions go from 2, 3, 4, 5, 6. That's it. So if I've got 6 fluorine, I have totally filled up the valence on the silicon. And you're going to just count your electrons then and see how many you've used to get that. And you have 8 times 6 is 48 electrons. Well, to get 48 electrons, let's count what silicon dumps in and fluorine dumps in. So silicon is in carbon's group, and so it's got 4 valence electrons, plus 6 times the halogens have 7 valence electrons. So 42 and 4 is 46 electrons. Okay, that's how many you had to place in the structure, but the structure itself has 48. So there's 2 extra electrons in the structure that don't come from the valence on the atoms. So the charge must be 2 minus. structure for ICL4 minus ion, give the hybridization and the shape. And it says hybridization of the central atom. Okay. So counting electrons 7 from iodine plus halogens have 7, so 4 times 7 is 28, plus the charge, 1 electron from the charge. So you have 8 and 28 is 36 electrons. Central atom bonds to 4. Complete the octets. How many electrons have I used? 8 times 4 is 32. I've got 2 pairs left to put on. 32 here, 33, 34, 35, 36. So how many regions do I have? So when it says draw the Lewis structure, I've got to draw the structure. So my answer is going to be this. It's an ion, has to be in brackets. And because it's how many regions? 6. If I wanted to take the time, I would not have to. So let's not, because you probably wouldn't do that on the test. We're always short. Okay, so that is lone pair, lone pair. That's the Lewis structure, and the charge was negative. So this would be my answer for the Lewis structure. So this is my Lewis structure. Now, once you've drawn the Lewis structure for the grader, don't mess with it. That's why I had to redraw it, because I started writing on this. The Lewis structure has to be perfect intact, no more writing on it. So then I go over here to answer my second question, which was hybridization and shape. So, what do I have here? How many regions? 1, 2, 3, 4, 5, 6 regions. 6 regions. How many lone pairs? So that's the octahedral electronic geometry, but I have 2 lone pairs change it. 2 lone pairs make it square planar. So I have 6 regions, 2 lone pairs, it's square planar. So this is my shape. And the hybridization, I need 6 regions, so that would be S takes up 1, you mix 3 P's. That gives me 4 regions. I need 2 more regions, so I need 2 d orbitals in there for the hybridization. sp3d2.